The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or fall in a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. In this video, I'm going to show you how to set up an LED matrix. You see these a lot on trains and buses. They're a great way to display long strings of text, and they're easy to see from a far distance. In this video, I'll show you how to set up a single 8x8 matrix, then I'll show you how to combine multiple LED matrices into a larger display. But first, let's get a closer look at how they work. LED matrices consist of an array of LEDs arranged in a grid. This display has 8 rows and 8 columns, with a total of 64 LEDs. There are a few different types you can get. This one has red LEDs, but you can get them with green or blue LEDs too. Some even let you control the color of each LED individually. The LED matrix I'll be using is model number 1088AS. It's a standalone matrix, so we'll have to connect it to an LED driver. The LED driver is a chip called the MAX7219. We're going to connect the MAX7219 to the Arduino. The Arduino will send commands to the MAX7219 over the SPI communication protocol. The MAX7219 will output the actual high and low signals that control the individual LEDs. As you can see, LED matrices have a lot of pins. This one has 16 pins. The MAX7219 only needs 3 pins to connect to the Arduino, so it cuts down on pin real estate considerably. Figuring out the pin numbers on these standalone displays can be a little tricky. This one has a number 1 under the resin here that indicates pin 1. There's also a number 9 that indicates pin 9. You can also get breakout boards with the MAX7219 already connected. These are much easier to set up. They only have 5 pins. VCC, ground, DN for data in, CS for chip select, and CLK for the clock signal. This is a standard SPI interface. On the other side of the board, there's another set of pins where you can connect additional displays. Since standalone LED matrices are fairly common, I'm going to show you how to use the standalone type and the breakout board type. But for now, let's get a closer look at how these matrix displays work. LED matrices consist of multiple rows and columns of LEDs. In this 8x8 display, there are 8 rows of LEDs and 8 columns of LEDs. There are also 16 separate pins. In my 1088AS display, there's an A printed on the side of the display next to pin 8. If you're not sure which pins are which, check the back of your display. There should be a couple pin numbers under the resin backing. Here's the schematic for a 1088AS LED matrix. I've labeled which pin connects to each row and column. These pins might be different if you're using a different display. The 1088AS is called a row cathode or column anode display. Each LED cathode is connected to a row trace, and each LED anode is connected to a column trace. Some displays are row anode or column cathode, and in these displays, the polarity of the LEDs are reversed to what's shown in the schematic. Each LED can be controlled individually. For example, to light this LED right here, you would set pin 4 high and pin 12 low. Now let's get a closer look at the MAX7219 so we can see how it connects to the display. The chip has 24 pins, and they're all kind of disorganized. There are 2 ground pins. Here's the VCC pin. DN is the data in pin. Dout is the data out pin. CLK is the clock pin. And this load, or CS pin, is the chip select pin. The I-set pin sets the maximum current supplied to the LED matrix. You set this value with a resistor called R-set that's connected between I-set and VCC. More on that later though. The rest of the pins connect to the display. There are 8 digital pins, D0 to D7. These connect to columns 1 through 8. There are also 8 segment pins, SEG-DP and SEG-A through SEG-G. These connect to rows 1 through 8 on the display. So if you're using the 1088AS LED matrix, the connections to the MAX7219 will look like this. The display pins are connected to the MAX7219 according to the tables I showed you earlier. If you're using a different display, you'll need to check the datasheet to determine which display pin is connected to each row and column. Then connect each row and column pin to the appropriate DIG or SEG pin on the MAX7219. If you are using the 1088AS display, you can use this wiring diagram to connect it to the MAX7219 and the Arduino. The DN pin is connected to Arduino pin 11. The load CS pin is connected to pin 10. The CLK pin is connected to pin 13. The VCC pin is connected to the 5V pin. And the 2 ground pins are connected to ground. Here's the R-set resistor I mentioned earlier. It connects the I-set pin to VCC. The exact value of R-set depends on the type of display you're using, and there's plenty of discussion on the web about the right value to use. But for most cases, a 10k ohm resistor works fine, and that's what I'm using here. Now if you're using an LED matrix on a breakout board with the MAX7219 already connected, the wiring is a lot simpler. As you can see here, all you need to do is connect VCC to 5V, ground to ground, DN to pin 11, CS to pin 10, and CLK to pin 13. Okay, now let's get to the programming. Adafruit makes a great library for controlling the MAX7219 and LED matrices called the MAX72XX panel library. It has lots of useful functions for drawing characters and printing different fonts. It also supports connecting multiple displays together. There's a lot more the library does that I don't have time to cover in this video, so if you're interested, check out the documentation for more information. The MAX72XX panel library uses another library called the Adafruit GFX library. So first you need to download and install the Adafruit GFX library from this link. Then you can download and install the Adafruit MAX72XX panel library from this link. Once the 2 libraries are installed, you're ready to start programming the display. Let's look at a sketch that will print a custom character to the display. The first thing we need to do is include the libraries. The MAX7219 communicates with the Arduino over SPI, so we need to include the SPI library. Since the Max72XX panel library depends on the Adafruit GFX library, we also need to include the GFX library. Here we declare an int variable called pinCS that defines which Arduino pin the CS pin of the Max7219 is connected to. In this case, it's connected to pin 10. The DIN and clock pins are already defined in the GFX library, so we don't need to define them here. The DIN pin needs to connect to Arduino pin 11, and the clock pin needs to connect to Arduino pin 13. Then we declare two more variables: number of horizontal displays and number of vertical displays. This is where you can set the number of horizontal and vertical displays if you have more than one LED matrix set up. We're just using one display here, so I've set both of these to 1. This line is where we create an object for our display. This is the Max72XX panel class, and matrix is the name of our new object. We pass it the pinCS number, pin 10, and the number of horizontal and vertical displays. Now we define the character we want to display. This is an array of bytes. See how there are 8 bytes? Each byte corresponds to one row of LEDs. There are 8 bits in each byte. Each bit corresponds to the column LED in that row. A 1 means the LED will be turned on, and a 0 means the LED will be turned off. This array will print a smiley face to the display. An array like this is known as a bitmap. There are websites online that will let you draw a shape on an 8x8 grid, and it will generate the bitmap code for you. These are a couple that I like. When you're defining the bit array, declare it as a const unsigned char. One requirement of using bitmaps with the Adafruit GFX library is that they need to be declared with a progmem variable modifier. The progmem variable modifier tells the Arduino to store the array in flash memory, instead of in SRAM, where variables are usually stored. In the setup section, you can call the setIntensity function, which will set the brightness of the display. I have it set to 10 now, but it'll take arguments from 1 to 15, with 15 being the brightest. Now in the loop section, we can print the smiley face we defined above with the drawBitmap function. This function takes 6 parameters. The first parameter is the x-coordinate of the display where the character will be printed from. The second parameter is the y-coordinate. So 0, 0 will print the bitmap starting at the upper left-hand corner of the display. The third parameter is the name of the bit array we want to print. The fourth and fifth parameters define the size of the bitmap when it's printed on the display. The fourth parameter sets the bitmap width, and the fifth parameter sets the bitmap height. This is an 8x8 display, so I have this set to 8 pixels by 8 pixels. That will print the smiley face with a 1:1 scale factor. But if you had a 16 by 16 LED matrix, you would set this to 16:16 to get a 1:1 scale factor. The last parameter sets the color of the pixels. The 1088 AS display only has one color, red. So instead of using a color value here, I've just set it to high. Finally, we need to use the write function. This function sends the bitmap to the display, so it needs to be placed after the drawBitmap function. So here's the completed circuit. I have the LED matrix connected to the Max7219, and the Max7219 is connected to the Arduino. there's the smiley face. So it's working. This is nice, but sometimes you're going to need to use more than one LED matrix. So now let's see how to set up multiple displays. Your best bet when using multiple displays is to use the breakout board type. Otherwise, you'll have to connect a separate MAX7219 to each LED matrix, and that would take a lot of wiring. With breakout board LED matrices, you can connect as many as you want and control them all with only 3 data lines. There are 2 sets of pins. These are the input pins, and these are the output pins. On this side we have VCC and ground. This side has VCC and ground pins too. There's also CS and clock pins on this side, and on the other side too. On this side we have a D-in pin, but on the other side we have a D-out pin. The D-out pin on this display will connect to the D-in pin of the next display. The Arduino will connect to the input side, and additional displays will connect to the output side. Let's build a circuit with 4 LED matrices and see if we can get some text to scroll across all 4 of them. So here I have 4 LED matrix breakout boards arranged side by side. Notice how they alternate with one set of input pins down and the next set of input pins facing up. That's just to make the wiring between the displays easier. So starting at the Arduino, the VCC and ground pins connect to 5 volts and ground. The data in pin of the first display connects to Arduino pin 11. The CS pin connects to Arduino pin 10. And the clock pin connects to Arduino pin 13. Now the output pins of this first display connect to the corresponding input pins of the second display. Just remember that here, data out on the first display connects to data in on the second display. The remaining 2 displays are connected the same way. Okay, now we're ready to program. This sketch is based on the Ticker sketch, one of the examples that comes with the MAX72XX panel library. A lot of the code in this sketch is a bit complicated to explain in a video, so I'm going to just point out the important parts. First we have to include the SPI, Adafruit GFX, and MAX72XX panel libraries. Then we declare the CS pin variable and set it equal to pin 10. Remember that the D-in pin has to connect to Arduino pin 11, and the clock pin has to connect to pin 13. Now we set the number of horizontal and vertical displays. We have 4 matrices lined up horizontally, so this is set equal to 4. The number of vertical displays is still 1. Now we create a matrix object and initialize it. Now this line here looks like we're creating a string variable called tape. But we're actually creating an object called tape from the Arduino's built-in string class. It's set equal to the text string we want scrolled across the displays. I'm just going to print a hello world here, but if you want to display some other text, you can change it. Just remember that the text needs quotation marks around it. Now we declare a variable called wait. The wait variable sets the speed the text will scroll across the display. This number is in milliseconds. As it is now, the text will shift by 1 matrix column every 50 milliseconds. If you increase this number, the text will scroll slower. If you decrease it, the text will scroll faster. These 2 variables are needed to perform the scrolling later down in the loop. Now in the setup section, we set the LED intensity with the setIntensity function. If you remember from the wiring diagram, the second and fourth displays were connected upside down to make it easier to wire them all together. So we need to change the rotation of those displays so they don't display upside down text. We can do that with the setRotation function. This function takes 2 parameters. The first parameter is the number of the LED matrix, which is 0 indexed. So the second display is actually number 1, and the fourth display is actually number 3. The second parameter of the function is the rotation. Starting from 0, which is no rotation, the screen can be rotated clockwise in 90-degree increments by increasing the value by 1. So a 1 here would rotate the display clockwise 90 degrees, and a 2 here will rotate it 180 degrees clockwise. And that's what we want. Down in the loop, we have all the code that makes the tape object scroll across the displays. Like I said, it's a bit too involved for this video, so I'm going to skip it. Okay, let's see what this looks like. There we go. The Hello World text is scrolling across the 4 displays. This is nice, but now let's scroll some sensor data across the display too. As an example, we can scroll the temperature reading from a thermistor. Don't worry too much about the specifics of thermistors. We'll learn how they work in a later video. The main thing here is to show you how to print sensor data that's stored in a variable. So here's the circuit I'm going to use. I have the 4 LED matrices connected the same way they were in the last example. But in this circuit, the 5-volt and ground connections are taken over to the breadboard. The thermistor is set up in a voltage divider, with one side of the thermistor connecting to 5 volts. The other side of the thermistor connects to a 10 kilo ohm resistor. The opposite side of the resistor connects to ground. The middle of the voltage divider is where we're taking our readings from, so that connects to analog pin A0. Okay, now let's look at the sketch. Most of this code is the same as the last sketch. We include the 3 libraries, define the CS pin variable, and set the number of horizontal and vertical displays. This block here is declaring variables for the thermistor calculations. Don't worry about that at this point, we'll learn about these in a later video. We create and initialize the matrix object, set the wait duration, and declare variables for scrolling. In the setup section, we set the LED intensity, and correct the display rotation of the second and fourth matrices with the set rotation function. Now in the loop, this block of code here takes a reading from the thermistor pin, performs a calculation, and stores the temperature in a variable called TC. Now we create the tape object from the string class. First, we print a regular text string that says temp equals. Strings can be added or concatenated to each other with a plus sign. We can concatenate the temperature value to the text string. But first, we need to convert the TC variable to a string. We can do that with string and the name of the variable in parentheses. This takes the TC variable, which was originally a float, and converts it to a string. We'll also want the units of temperature, so let's concatenate a C for Celsius after the sensor reading. The rest of the sketch scrolls the tape object across the displays. So let's see how this looks. Alright, so it seems to be working okay. Let's see if I can get the temperature reading to increase. Yep, there it goes. It responds pretty quickly, and the text is pretty easy to read too. In the next video, we're going to look at character LCDs. Character LCDs are another way to display information on the Arduino. SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.